The topic for today is open source generative AI for test automation. Kind of an interesting topic that I had a fun time preparing for. It's not something I would say I was an expert in previously, but like all of us, I think we're trying to come to terms with the role of AI in our work. Oh, good. I see some folks chatting from South Africa, Uruguay, Emirates, Dubai, UAE, SF, San Francisco. Excellent. India. Wow. All over the place. I love it. Um, Very cool. Let's see. A little bit about me. You might know me from a test automation project called Appium. We focus on, giving you tools to automate your tests on mobile platforms or other platforms. Um, and I also work for HeadSpin, who's hosting this webinar. And HeadSpin has a cloud platform where you can run your automated tests using Appium or other frameworks, and then get a lot of interesting insight into data that arises from your tests, how your app is performing on a variety of dimensions, things like that. So I am an engineering director here. So I lead what we call our product engineering teams. So the stuff that our users end up working with, and that's a lot of fun. Uh, I'm Jay Lips on X, formerly Twitter, um, LinkedIn, GitHub, most places. So you can follow me there if you want to hear other things that I have to say. Ooh, some more locations rolled in. Atlanta, Seattle, London. My goodness, this is awesome. I guess the other part of my background that's important for this webinar is that I've always been a little bit skeptical of the role of AI in our work. Not to say that I haven't been impressed, like everybody, with the amazing demos and capabilities that it represents, but in my early explorations, I didn't really see a whole lot that made it feel like it would speed up the kind of work that I do. Um, so I don't know. I always think it's good to be a little skeptical of any over or any technology that's getting a lot of hype because it might be overhyped, right? So that was part of why I wanted to run this webinar. I wanted a good excuse for myself to dive into some of these technologies and see what could be done. So let's talk a little bit about what Gen AI is. First off, it's a species of AI when AI doesn't really mean anything, as we all know. Artificial intelligence just means computer systems that look smart or act smart, but it doesn't say much about what they actually are. But today we tend to refer to large machine learning models, usually neural network based and things like that, as the kind of AI that is exploding and providing a lot of hype and probably utility as well, all around. So Gen AI specifically lets you give kind of input to an AI model via natural language prompts. So just like you would talk to another person, and then you get some output which corresponds to what you ask the model to do. This is kind of the magic of it. You can ask a model to, produce some text that corresponds to a certain style, and the model will generate something new that presumably doesn't exist yet in the world, although a lot of times it does kind of, draw from existing content and sometimes copies it exactly as people have seen. But to us anyway, as the user, the magical part of the experience is that these models seem to understand what we're asking for, and can even kind of mimic a kind of reasoning, can do analysis, summarization, answer questions based on a context, things like that. Most popular uses I see for Gen AI today, just generally out there in the world, are producing and summarizing writing. So people trying to get insight into a lot of content, asking for summary or analysis, and also producing novel like images and video, right? So making up cool pictures or videos that didn't exist before just by describing them. More relevant for us as developers and testers, Gen AI models can also generate code. There's nothing, I guess, magical about code when it comes to what these AI models have been trained on. And I guess you could imagine that structured language, like a programming language, and a very minimal language, in fact, might even be easier for Gen AI models to learn and quote unquote reason about. So there's a lot of these tools that are available that many of you who took the survey that I ran have used, including GitHub Copilot. Google has one called Gemini, Vercel, obviously ChatGPT just can generate code. And some of these are more kind of helpful assistants, and some of them, are kind of high-level code authors themselves, like the Vercel application here. You just kind of give it what you want to have developed, and it'll kind of generate entire programs, websites, things like that for you. So this is basically GenAI, how we're thinking about it. They can also be linked up with, other bits of software that do things in the world to kind of create, what feel like autonomous agents that are working on your behalf. So not just producing content, but also executing instructions. And that takes a little bit more work than just the language models or the generation models themselves, because they're just generating things. They don't know how to do stuff in the world. But when you connect them up with other APIs and the ability to call out to external functions in the world, then you can get some pretty powerful behaviors. So specifically for test automation, I've been trying to think what are some applications of this technology for test automation, and I've got no doubt very incomplete list here. And if you have other use cases that you're familiar with or that you've thought about that I don't mention, I would love to hear about that in the Q&A time. So feel free to share about those with us. But I see, test automation, especially when you're, writing large test suites, is a kind of software development. And so it's possible to use these coding assistants like, GitHub's Copilot tool to assist in writing test code, just like it is possible for writing app code. So there's kind of general coding assistants that, you might not. I'm trying to think of a really easy example here, but you might say, write me a user login test, and it will generate the bones of that test function for you, and then you can tweak it rather than having to kind of come up with that yourself, especially if you're newer to, let's say, Selenium or Appium or one of these other automation tools, and don't want to be bothered to go look at the documentation. You can say, write me some Selenium code that attempts to log into a web application. Another use case could be developing your tests using natural language. So your end goal here would be to have a bunch of test code, and kind of like I just described, you could say, tell the AI model that, like, I want these 5 tests, test cases, and lay out the steps for each test case. So kind of like what someone on your agile team might do, right? Someone who's coming up with the test plan. They might have the plan and then give it to the tester to say, implement this in code. It could be possible to just give that plan to an AI model and have it generate that test code. Whether or not the code actually works or is the best code, I haven't been super impressed on that level, but certainly somewhat believable code can be generated in this way. There's also kind of taking that one step further and having the model not just generate the test code, in fact, making the test code itself kind of unimportant, by pairing the model with some kind of execution engine and having it be the thing that's actually running the test. So telling a model, you know, I want you to walk through a login flow in this application that I've, just opened up and I've never seen before. And, have it kind of reason its way through that process without needing to write test code yourself. And again, there are pros and cons to maybe turning this process over to an AI model and whether that's a good idea uh, to put into an actual test suite for an app that you're responsible for, a completely different question. But it seems like this is a thing which is possible and has been demonstrated. A much more kind of scaled back use case would be something like using AI models to help discover element locators that you then use in the test code that you're writing. So you're maintaining control of the test code, but you're just kind of using AI to make this kind of unpleasant process of finding, good quality element locators a little easier. Um, or another, even higher level goal could be to have the AI model help with coming up with a test plan in the first place, right? So this is typically very much in the domain of the human, to say what is it that we need to test. Say you're working with a new app and you just want some ideas, right? People use these large language models quite frequently now as idea generators, right? You could ask it, I have an app that lets you do X, Y, and Z. What are some things that I should test? And it might come up with ideas that you hadn't thought about. Whether that makes you better or worse at your job, I'm not sure. But that is a thing which, this could be useful for. And then, finally, we could, imagine just turning over the entire job of testing to AI agents at some point. Not sure we're there. I know that people are working on this, but you could just give a collection of models and execution engines a bunch of apps or a single app or whatever, and say, um, you know, figure out what to test in these apps and test it, and give us a report of what you found and if you found any bugs or crashes, right? And then you just kind of go away, and then the agents work on the app and deliver back a report. Um, Again, that's probably not going to be really useful in terms of like high coverage regression testing, but it might be very useful in terms of discovering things about your app that you didn't know. It might be very a big time savings depending on how many apps you manage and the size of your team, things like that. So these are all kind of use cases for this pretty remarkable new technology. So let's go into the results of the survey that we ran in the lead up to this webinar. We'll kind of blast through it because I want to spend time elsewhere, but I thought it was pretty interesting. People's level of experience using GenAI tools. Fair number of people never used it before. Fair number of people use it daily now, and then there's a bunch kind of in between. So that was kind of interesting spread there. Everyone's all over the place. Level of experience using GenAI tools to assist with test automation. Again, about half the respondents haven't tried that, and some of them tried it, but rejected it for one reason or another. Only a few people, I guess, I don't know how many people did the survey exactly, not, somewhere less than 100, I think. Uh, Few of them actually use it daily or weekly, and we'll dig into which tools they use a bit later on. What sort of tools people use? Generally, it seems to be a mix of paid, free, and self-hosted or open source tools. Although when I dug into the list of tools that people provided, I couldn't actually find any truly open source tools in there. That's kind of what this webinar is focused on. So I thought that was interesting. And if you use GenAI tools for test automation, what sort of tools do you use? This is trying to get a different dimension of that same question. Most people who use tools seem to use text to code tools. This is like, GitHub Copilot or ChatGPT or whatever. So saying, give me the code for this thing that I want to do. So kind of code generation tools. That's kind of the most popular category. Some people said AI-driven testing, where AI itself is the thing that's kind of driving the tests. Although again, when I looked into the list of tools that people people gave, I didn't really see any that were advertised as doing that. So I'm curious if we have some different understandings of what that means potentially. If people tried but don't use GenAI tools for test automation, the reason, um, the reason, are kind of all over the place. But one of the most common reasons was that the quality of the output wasn't that high. So the red one here was that the prompt didn't apply to them, meaning that they didn't actually try it. So we can kind of ignore that slice. So the next highest slice was that the quality of output was not good enough. Um, the next biggest one is that there wasn't enough significant return on investment for it. So what that says to me is that for people that are kind of early adopters of this technology, there's still a whole lot of rough edges, and it might be a little more work or a little too reliable to make it really worthwhile still. And this is GenAI tools across the board, open and closed source. So that's interesting to see. And then people's outlook on the promise of GenAI. Most people would say that they kind of put GenAI into the category of a useful assistant. So not kind of taking over the whole process, but being a kind of smart aid for human test authors and test developers. A few people thought that GenAI would take over everything. Not that many. Some people thought that it would never be reliable enough to be that much use. And a lot of people, this is the red slice here, thought that because GenAI will sort of take over some of the lower level responsibilities of test development, that humans would be able to work at a higher level. So things like coming up with test plans and stuff like that. So yeah, this was sort of the tenor of people's attitudes from the survey, which I thought was pretty interesting. Oh, we've got another one. Yeah, this is an important one. This is a list of tools that were mentioned that people use specifically by name. So again, the most popular, which is probably not a surprise, is ChatGPT, followed by GitHub Copilot, and then there's a lot of more specific kind of tools that were used by just one or two folks. So that I think is the end of our survey now. Yes, good. So we're talking about in this webinar specifically open source GenAI tools. I made this kind of restriction on the scope of the topic for a couple reasons. One, I just care about open source a lot, and I've been working in the open source world for a long time. Two, there's already a lot of content out there for all of you on GenAI tools in general with respect to testing. There are dozens of companies and products that are advertised as GenAI tools for test automation. So I figured, everyone is more or less aware of that. But what I haven't seen discussed very much is how you can use any of these tools in a purely kind of free and open source way, whether that's even possible. So for me, it was kind of an open research question, and this webinar is where I'm going to tell you what I found. And I won't steal my own thunder, so I won't tell you what I found yet. But let's look at what some of the open source tools are out there. One that I found, which was pretty interesting, it's called Lavag, and basically it pairs large language models with the kind of action model as well. And the purpose of it is to use natural language to drive an agent through a web application flow. The purpose of it is not really for testing. It was developed as kind of like a personal automation assistant. So like, let's say, one of the examples I think they have on their website is you want to, fill out a resume, like you're applying for jobs, and you go to each company, and each company has a slightly different form and process for applying for the job, but it's ultimately all the same information. And so you could use Lavag to say, go to these 20 different websites. Here's my information. Find out where the information goes in their specific forms and submit the resume for me. and it actually uses Selenium under the hood as part of the action model there. So you could imagine this could be applied to test automation as well as a way of kind of telling an AI agent like I have this flow that I want you to walk through, figure out how to do that, and it sort of mimics the way a user would look at a screen and reason about what sorts of things are possible to do on that screen. The agent has a goal it's trying to accomplish, so it tries to use the available elements in order to accomplish that goal. So there's definitely some overlap there. This is a very interesting project. It's backed by Selenium at the moment, so won't work on mobile devices. Although I've talked with the creator of Lavag and hope to follow up on maybe seeing if it's possible to hook in an adapter for Appium. So I think that could be interesting. But yeah, it's not really designed for testing. Also, how well it works depends on the language models which are used to drive the whole thing. And the examples tend to be around ChatGPT, which obviously is a closed proprietary model. So its openness kind of depends on which models you use for it and its speed as well, which is something we'll come to as a big difference between kind of running local open source models versus using paid models via online APIs. And honestly, that was kind of it when I did some research. So again, if you have other examples, I would love to hear about it in the Q&A. I couldn't really find a whole lot else in terms of GenAI tools for test automation that weren't, provided by a company that was trying to make money off of them. So yeah, it felt like kind of a desert out there in terms of open source, which from another way of looking at it is an interesting opportunity for people to work in this area. What there are a lot of are open source AI models that companies have offered to the world or to a scientific research community to help drive forward AI development in general. So there are a bunch of these, and there are even models which are called multimodal models that let you have as your input not just a text prompt, but also send in something like an image, which is really useful for test automation because at least humans generally use applications via screens. There's a lot of visual information, that we can get from the screens, and that's how we, typically humans walk through applications. So being able to send that information to an AI model is very useful. There's also a great kind of repository of models that's kind of the standard in the community. It's called Hugging Face, and it's kind of like I guess, a GitHub for large language models and all kinds of AI models and machine learning models. So it's really easy to use to, download versions of these models and interact with them in kind of a standard interface, which is really convenient. Some of the models that are popular, which are out there right now, there's one called Llama from Meta, which has quite good performance. There's a company called Mistral, which is releasing some open source models that have gotten a lot of recognition. Google has one called Gemma, which presumably is related to Gemini, but this is their kind of open source version. I'm not exactly sure all the differences. There's one called Bloom, and lots more, like hundreds more. And then these have all been kind of mixed and remixed by the community in ways which add additional fine tuning or provide additional capabilities to models. Honestly, it was quite overwhelming to dig into this, so I only got so far into understanding this world of large language models, and I tested a few of them, and so that's kind of what you see here. But it's clearly an area that you can totally get lost in if that's of interest to you. So the experiment that I tried to work through in order to help me understand how to, use these open source AI models was to, build something because I think that's the best way to learn. And being kind of the Appium guy, I thought, let's combine these things. Let's try and build an LLM plugin for Appium. LLM standing for large language model. It's the category of generative AI model that we find in like ChatGPT and so on. It's been trained on basically the entire internet. You ask it, you give it a prompt in text or a multimodal prompt, and it generates an answer for you to whatever you're asking. So here's what I thought I would do. I wanted to develop a couple ways to give app information, so like where we're at in a test automation flow, like the state of an application, to an LLM, so that we can then use natural language to find elements to interact with in the application, some element that we're interested in, either via the UI itself, like a standard WebDriver element type thing, or via coordinates, i.e. where is the element on the screen. Then the next step, I guess one thing I should say about this step is basically I'm thinking about the use cases that I mentioned earlier. And this is the use case of an AI assistant that tries to find element locators for you. Although in this case, I'm not asking it to find the locator to give to me to put into the test code. I'm just asking it to use its own, internal logic to take my natural language description of an element and then give me an element reference back that I can use to click or send keys to, or something like that. So it's kind of, I guess, a hybrid of a couple of the use cases that I mentioned earlier. So that was the idea for this plugin. So the next step after, developing ways to get the LLM to work with app data and give us an answer back using, some clever prompt engineering or whatever, is to create an Appium plugin around this with a new locator strategy, which I'm calling AI. And this new locator strategy lets you send in as a selector just a string of text that in your mind describes the element that you want to interact with. And then that is what is sent over to the AI model, either a local model, one of the ones I mentioned before, an open source model, or something closed and paid like ChatGPT. I also wanted to do some comparisons between you know, locally hosted models and the kind of flagship professional models out there that people are paying lots of money to use, just to get an idea how they relate. So that was some of the testing that I did, and I was curious to see also if any of the modes of using this plugin are better than others. I'll talk about what modes I ended up developing in a minute. So let's talk about first how you run LLMs locally, if that's what you want to do. The best way that I found is to use this really well-designed app called LM Studio. Basically, it's just a GUI app that runs on your desktop, and it has a browser and a search tool for downloading, managing models from this Hugging Face repository site that I mentioned earlier. And it lets you actually load a model into memory and run it, exposing a web server that mimics the OpenAI API. And OpenAI is the company that maintains ChatGPT. They have a kind of API that people use to build apps on top of ChatGPT. LM Studio uses that same API, and it lets you make queries of whatever LLM you have hosted locally, which is pretty cool. And it lets you use the OpenAI API client, so you can, either talk to your local model or talk to ChatGPT or whatever using all the same code. So that seemed like the best setup, especially for a kind of quick project like I was trying to work on. And I was really impressed with LM Studio, how well it worked after trying to run some of these models locally using just, for example, Python libraries, I ran into a bunch of different issues that were quite frustrating to work through and time consuming to debug. And LM Studio let me just click a button and have the models running behind a convenient API. So that was what I decided to build the plugin around. And as I said, um, with LM Studio, you can use an OpenAI client, but talk to the local model as well. This is what it looks like. Here I've got a model called Obsidian loaded into the local server, and it you don't need to examine any of this text in detail, so don't worry if it's too small to see. But it's quite convenient. It gives you a log here, so you can see what prompts are being sent into the model and what text is generating, or what kind of response it's generating in real time as it's generating it. Gives you a bunch of nice examples of how to talk to the model using curl or the OpenAI API clients. So that's how I decided to get these open source models running locally to test with the Appium plugin. Here's how I designed the plugin to work. It's a fairly straightforward idea. You've got your Appium client where you're writing your test code, and you get a new locator strategy. So I'm calling it find by AI here. This isn't actually a method that exists in your Appium client today, but you imagine that it could, as it's just a new locator strategy, along the same lines as ID or CSS or XPath, accessibility ID, etc. And what you do is you pass in the a description of the element that you want to find. So you could just say like the login button. And the idea is that hopefully the AI model will figure out what that means in a robust way without you having to know exactly what selector applies to this element. That gets sent to the Appium server where the plugin is running. Then depending on the mode that we're using to query the large language model, we get either the page source or a screenshot from the device. And then we combine that into a prompt. So the question that we are forming for the model, that gets sent to the model server. So either, OpenAI itself, if we're using ChatGPT, or LM Studio's local server, if we're running a locally hosted model. That gets churned through the model, and it does all its magic that we don't entirely understand. And then what gets sent back is, the information that we requested. So depending on the mode, that might be something like the position of an element on the screen, or an XPath selector that we can use to find the element, gets sent back to the plugin. The plugin turns that information into an actual element reference. And it's that element reference which is sent back to your client, and you can then interact with the element by clicking on it or whatever, the way you would normally do when using Appium. So that is how the plugin is set up. And as I mentioned before, we have a couple different modes to use the plugin in, and these are kind of all just experimental ideas of ways that it might be useful to use the model to help find an element. So we could definitely think of more modes. Some of these modes might be non-starters. Some of them, one in particular, just kind of didn't work that well. So anyway, for now, what we've got is a screenshot mode where the context that we send to the model is the current screenshot from the device. The prompt that we send, it's actually much longer than this, and I've spent a lot of time trying to fine tune this prompt to actually get a decent result. And this is the weirdness that is prompt engineering with AI models these days. But essentially, it's the question: what's the bounding box of the element in the screenshot described as, and then whatever description you sent in, for example, the login button. And so then what the plugin will return to your Appium client is something called an image element, which you might be familiar with from the Appium image plugin. It's kind of a fake virtual element because we don't actually have a reference to the element in the underlying test automation framework from iOS or Android. So we can't do things like send keystrokes or, get the text from the element or something like that. But because we know where it is on the screen, we can do things like click it. So um, typically what you want to do with elements anyway is tap them. So that's what you get back to your client. You can call element.click on it, and hopefully the AI sent back something that was correct, which is not always the case. The next mode is called XML. And what we send to the model in this mode is the current page source XML. So the kind of machine-based description of the UI hierarchy with all the kind of metadata that we can get from the accessibility systems on the device. So things like what the ID or label of an element is, its position on the screen. That's kind of about it. We don't get a whole lot of information about elements from iOS and Android. And then the prompt we send over is basically asking the model to look at that XML, find the element that we're describing in the XML tree, and then give us an XPath selector to get to that element. So in my mind, this was kind of a big ask, right? It requires a couple large things from the model. One is to find the XML node representing the element we're describing, and two is to kind of reverse engineer from that node an XPath query that will find that node in the XML document. Surprisingly, this worked decently well for some of the models, so I was pretty impressed by that. And because what we're getting is an XPath selector, the plugin can turn around, apply that XPath selector to our kind of traditional find element call, and get back a full element reference. So you can do the things you would normally expect to do with an Appium element, including get attributes from it, send keys to it, things like that. The final mode that I experimented with, I was calling XML position, just to have a short way of talking about it. Kind of a mashup of the previous two modes, really, where the context that we send to the model is the XML source, so not the image, screenshot image, but the XML hierarchy. And because the XML hierarchy actually includes the position information for each node in the tree, I thought it could be a very simple question to ask the model, find the element node that I'm interested in with a certain description, and then give me what the bounds attribute on that element. And on the Android source, this is just a single XML attribute. So it's a pretty easy operation to just say, what is the value of that attribute? And this is only Android for now because the XML structure across iOS and Android is quite different, and I only taught the model how to understand the Android schema, basically, although it would be straightforward to make this work for iOS, I think, as well. In fact, I did all my testing just on Android for this, but the previous two modes should work just fine on iOS. There's nothing Android specific about them. And what this returns is an image element, because again, all we have really is the on-screen, position and width and height of the element. We don't actually have a reference to it from the perspective of UI Automator, XUI test, that kind of thing. So the way you use the plugin, just like using any other Appium plugin, obviously you have to have it installed and start the server with the plugin active. And then we have a bunch of new capabilities that are either required or optional. This is all in the documentation, which I'll link to. You have to do things like say which model you're using, which of the three query modes you want to use, something called the temperature, which basically indicates how creative you want your AI model to be in composing its response. And as you might expect, you don't want it to get too creative when responding to this. You're not having it generate something artistic or something that you want to be really different from invocation to invocation. You really want something accurate and ideally kind of the same each time you run a test. So a low temperature I discovered to be better. I don't know if there's some kind of universal rule here. I found that a temperature of 0 did not work that well. I just settled on 0.2 because it seemed to work fine, but there's probably a lot more wiggle room here and experimentation that needs to be done. And then, which AI server you want to talk to, whether the local LM Studio server or something like OpenAI itself. And then the way that you would use it in your test code is to use this new AI locator strategy. So the way that you use a kind of arbitrary locator strategy might differ from Appium client to Appium client, might not even be possible in some clients, I don't know. But we have this AI locator strategy, and then you pass in a selector that's just a natural language description of the element that you want to find. And then what you get back is a reference to that element, and depending on the query mode that you used, you'll either be able to click on that element or do all the normal element things with it as well. Okay, it actually sort of works, which I did not believe would, totally be possible. So that's kind of cool. Let me show you a quick demo. I'll switch over to a video. I definitely did this using a video rather than wanting to do a live demo because it's a very, very slow process when you're using a local model. So here is the video. It's kind of blurry. That doesn't matter. You don't need to see any text that's on the screen. I've got some test code here, and I'm kind of developing the model, and we're going to run an Appium test. So what it's going to do is load up a simple application, the Android emulator, and then I've got LM Studio running here, and it's receiving the query, and then I fast forward, and then here's the response, and we got the element that we were interested in. Now we're going to try and tap the login button, and that works as well. So I'm going to go ahead and talk through this a little bit more. So again, once the app opens up, all we're doing is saying, find me, I don't remember which selector I use exactly. I said something like, find the login screen list item. And so that gets sent to the model along with the XML source. And then it takes, I don't know, about a minute. It's very, very slow running locally. And then it gives me back a bunch of tokens that I parse as the location of the element on the screen. And then Appium attempts to tap that location. In this case, model got it right. We went to the place that I intended to go. Then we do the same thing again. I just have it try and tap the login button, and we're expecting to see this invalid login credentials pop up here in the application. And so that's the extent of the test. But it kind of works, which is pretty interesting. Okay, sharing my presentation again. There we go. Right, so if you want to check out this model, it's up at the HeadSpin open source organization under Appium-LLM-plugin. We'll share this recording, this link, so you don't need to get too worried about missing it right now. I will say that it's under heavy construction. I'm not sure if I will be continuing to construct it. We'll see if it's useful. It probably doesn't work for many cases. I didn't go and try a bunch of different apps and a bunch of different locators and things like that. I was just trying to see if I could get the model to return useful information in some way or another, and surprisingly that worked. I did encounter a bunch of challenges along the way. A lot of inaccuracy here with the model generating false or non-existent info, which was unhelpful, and no real way to debug other than kind of tweak your prompts and try again. Unreliability, by which I mean, it gives different answers from run to run, which is good in terms of how these language models were designed to produce content which is novel. But when you're running a test suite, you don't really want novel content. You want correct content. And once you have the right answer, you want the same right answer a million times in a row. But that's not really the way that these models were designed to work. So again, it highlights the difference between an actual agent, which really understands what it's trying to do, and one of these models, which really is only mimicking that kind of understanding, although it's doing it in a really impressive way. I found it frustrating to work on the prompts that get sent to the models, because there was no real way to say, I know what the prompt endpoint should be and I'm going to work on that. You just kind of try a bunch of things and tweak it until it works. So in that sense, prompt engineering is very different from software engineering, right? Where software engineering, you have a goal, you make a hypothesis about how to get there by, building a certain type of software architecture, you build it and it works. In this case, prompt engineering is more like, well, let's let's see if the model likes this, or let's see if this helps the model understand things better. And you might get further away from the goal the more you try. So it's a strange kind of work to do, in my opinion. Context windows not being large enough. Some of these models only let you send in so much context, and if you have a large page source, for example, you might not be able to get the entire XML hierarchy into the model, and then the thing just doesn't work at all, at least for those modes. So that was kind of frustrating. I ended up making it work, but I could imagine apps that have much larger um, uh, hierarchies than mine maybe just wouldn't work with this at all. And as I mentioned, these models, when I have them running locally, very, very slow, not performant at all. You can't be bothered to wait a minute to find an element. It's just a non-starter. Um, but again, this is a proof of context, and presumably there are ways to speed these up, or host them on, beefier machines and things like that. Also, the AI will happily make up stuff, right? So having it know that there's not actually something on the screen that you're looking for is a bit of a challenge. So you give it a description and it'll say, well, here's the thing that I think most closely matches that, but it might not at all. And so I found it to be difficult to tell it to, try and teach it, I guess, to say, no, there's nothing on the screen that matches what you're talking about. So yeah, a lot of challenges to making this experience something that I think is actually worthwhile incorporating into an actual test suite. Oh yeah, and I was testing a bunch of different models and found that trying to make a prompt that would work for better for one model might make it work worse for another model. So in some way, it seems like you might have to tie uh, your AI product or whatever to a particular model if you want to get really good accuracy out of it. But then that's a form of kind of lock-in, even if the models are all open source, which is unfortunate. Quick comparison of the tests that I ran using different models. On the right, we've got the 3 different modes. And what the little colored circles mean is basically a green circle means something worked. There's sort of 2 columns in each of these cells. The left-hand column is, could I get the model to respond in the correct format such that I could actually use it in the plugin reliably? The right circle is, did the model actually return correct information reliably? So the left-hand side again is, it was the form usable, and the right-hand side is the content usable. And then I added some annotations as far as speed goes, on the ones that actually worked decently well. So the screenshot mode was tricky. I didn't really get anything that worked well there. Only a couple of the models would actually return something that was usable at all, and even the usable formatted information was often incorrect. So even with the fully paid GPT-4 model, I couldn't get this fully working, and most of the other models, wouldn't even return something in the correct format for me. So either I need to fix the prompts, or this is just not super viable at this time with the current state of the models. The XML-based modes fared a little better. ChatGPT 4 did a great job, and the local open source Llama 3 model from Meta also did a great job. Both of them had similar reliability, although Llama 3, which I think was the one used in the video you saw, was extremely slow, and ChatGPT was a lot faster. So ChatGPT would return a response in 1 to 2 seconds, and Llama 3 would return a response in about a minute or something like that. And again, this is an artifact of a consequence of the fact that I am running Llama locally on my machine, and OpenAI is running their ChatGPT server on undoubtedly the most powerful machines that exist. So that's not a surprise. None of the other models really did all that great. So this was an interesting experiment. There are many more open source models to test, but I think this gave me a taste of sort of the state of the art in open source models, and some of them are much better than others. It's worth pointing out that Llama 3 is open source, but you have to kind of sign a very unique kind of licensing agreement with Meta and give them your contact details. So it's not as open as we're used to in some ways from open source, although we're used to this kind of thing from Meta and other areas as well. I want to leave some time for Q&A. I'm running a bit over, so just a few thoughts for further development of this type of thing that I'll leave here. Whoops. We could do more fine tuning. We could do more tweaking. Obviously, that's a big part of the job here, which I didn't have a lot of time to do. Could find better hardware to run these models on. And there are, I think a lot better uses of GenAI than these ones that I came up with. These are just the ones that seemed possible to achieve within my scope. But GenAI's strengths are really about producing novel content that matches some criteria. And we're not really interested in that all the time in test automation. We're a lot more boring, right? So I think there's a little bit of a natural tension here between what GenAI is really good at and what we really need in test automation. So that was a kind of interesting insight from this process that I didn't think about beforehand. Obviously, the plugin I developed is open source, and you can come and mess with it with me if you want. Some overall thoughts to conclude on kind of the state of GenAI for testing. I would say that open source is not great right now. Some of the models, at least the Llama 3 one that I tried, are extremely powerful, seem to have a lot going on for them, but running them at scale is going to be a big challenge. And it seems like the most effective way to use GenAI currently is in a closed or paid solution, which isn't my favorite thing, but is perhaps not surprising given how expensive it has been to develop these models, and how much of the Earth's energy has been burned developing them. So that's not a surprise, possibly. I personally found working with GenAI to be a bit more frustrating than simply doing the thing myself. A lot because of what I mentioned before about how prompt engineering, it feels kind of like a magic art rather than a real science or a real skill. You don't really know when you sit down how long it's going to take you to do the thing. The way when you sit down to write some software, if you've done it for a while, it's generally a skill that you've cultivated and kind of have a good sense of what you're doing and how long it will take you to do, and that the end result will be reliable because, again, you know what you're doing and you don't have to trust that some code that's been generated, it doesn't have any bugs. All the bugs in your code are just your fault, which is in some ways a relief. Also, just noticing again what many people have noticed, that GenAI is often confidently wrong in its output, which is bad if we're turning to it because we don't know what we're doing. Because if we say like, well, I don't have the skills to do this job, I'm going to let GenAI do it, and then it does it, but it does it in a way that's subtly wrong, we're not going to have the understanding to know exactly what's wrong about it, and the ultimate state will be kind of worse than if we had just spent time learning how to do the thing ourselves in the first place. So I'll pause there, and I know we just have a little bit of time. I'm happy to go a little bit over than our allotted hour here to work with some of your questions. So move right into that. I think I have access to the Q&A panel. Where are we? I'm going to kind of go through and pick ones that I think will be interesting to discuss. Yeah, so here's a question from Paresh. By finding elements at runtime with AI, don't we miss the issues with unexpected UI changes? Um, I think what this question is saying is, does this help us avoid issues with unexpected UI changes? And I think that's part of the motivation for this is that by giving a higher level description of an element, we're less tied to specific attributes of that element, which might change from build to build, right? So if we're using a natural language description of an element, we don't need to worry if the developer changes the test ID of the element and breaks all our tests, because supposedly the AI model will be much more flexible and much more quote unquote human in how it finds the element. If a user wouldn't be surprised at the change of an ID of an element because it's still there on the screen and still has the right, description on it and so on, then the AI model is not likely to be surprised about that either. At least that's the idea. So yeah, that's part of the promise of this overall use case. Devon asks, for your local Llama 3 test, what kind of hardware were you running on? I'm on an M1 MacBook Pro that was, top of the line, maybe 3 years ago. So not the most powerful machine these days. I didn't try and do any special kind of optimization. I believe that it was offloading the entire model to my GPU, but I'm not sure. And I didn't spend a lot of time trying to tune performance. I was just trying to, again, get this working as a proof of concept, so that there are probably ways to, greatly improve that, either by tweaking hardware or tweaking settings or making sure that I wasn't running a million other programs at the same time, and so on. I'm curious to see if the M2 or M3 chips might do that a lot faster. Let's see here. Peter asks, it seems like even if AI gets to the point where it can efficiently test software, do you think there will be a need to test the results? It seems like there could be a huge risk in trusting something that we don't fully understand or control. Yeah, I completely agree, Peter. I think, I ended up saying something similar to this just now. Um, if we allow GenAI tools to develop our test suites for us, then we're responsible for making sure that they've done that correctly. And how much work is that, right? Is that at the end of the day, is babysitting the AI, less work than just, developing a test suite that we know works because we designed it ourselves? It's unclear. It's also a good question to ask, is babysitting an AI more satisfying than just writing tests? People might differ in their opinions on this, but you could imagine that writing tests is a craft, a skill that can be developed, you can take pride in. It's unclear to me right now whether babysitting an AI and checking it for correctness is something which could be a craft or a skill that I could take pride in. Maybe. Again, we could have a philosophical debate about that, but it's worth thinking about. Unable to find the plugin on GitHub. I believe that I made it public. I know I had it private for a minute. Anyway, I'll need to double check that. I'll do that after this call. But the link was there, so try it again in an hour if maybe I forgot to actually open it up as I was developing it. David Broker, hey David, did the model have to be taught specifically how to find elements, or does that all come from the prompt itself? So this is actually a good question. I meant to say something about this. All of that came from the prompt itself. So, my prompts were paragraphs long, kind of talking about this is the kind of input you, the model, are going to receive. Here's what I want. Do this, don't do this, because, the model's output naturally is to include all kinds of explanatory text and things like that. And I said, avoid all that, etc. I think there's probably room to create some, fine-tuned models where a lot of this stuff is put into the model itself. And so it doesn't need to be put into the prompts, which could make the prompts shorter, which could make getting the answers faster. Didn't experiment with that, but it would be interesting, if somebody who knows about model training and fine tuning wanted to do that with a bunch of kind of test automation related inputs. I think that it could probably be the accuracy and performance might be improvable in that way. Let's see here. Abhijit asks, can we develop element locator models using TensorFlow and train it on our app UIs instead of using GenAI for now? Yeah, honestly, I think that something like that might be more accurate use of AI than LLMs. For a use case like this, I know that there was a company a while back called Test AI that basically did this, trained an AI on essentially app screenshots and hierarchies so that you could try and do something similar. And I would wager to say that it had probably quite a bit more reliability and accuracy because it didn't need to be a large language model that had a bunch of extraneous unnecessary utility for our purposes. It was specifically trained on this question of turning a natural language query into an element locator. So yeah, I do think that there's a lot of room for research in AI models that aren't kind of these hypey Gen AI models, but might be more targeted and more useful for test automation. And I know Test AI open sourced their model data at some point. I don't know if anyone has done anything additionally with that, or if that's been kind of mashed up with the current generation of AI technologies or not, but that could be an interesting starting point for that idea as well. Sravan, hey Sravan, curious on the future plans on this project. I, like many things I do, made it as a demo for this webinar. So I kind of am putting it out there as an interesting idea. As an Appium plugin, you're free not to use it. You're free to mess with it. I think it could be cool if other people wanted to help hack on it. I'll try and maintain it as far as possible. If it seems like there's promise, I might work on it. A bit more. But honestly, for the time being, it's sort of a proof of concept. So yeah, if you're interested, feel free to start collaborating on GitHub there. Let's see. Well, we're 5 minutes over, and I've answered most of the questions I think I can give a good answer to right now. So I'm going to probably call that at the end there. So again, we'll make this presentation video available for you later. And it's been my pleasure being here with you all, and thank you for your attention and engagement. And yeah, let's keep thinking about how these new technologies are useful or not, and how they're impacting the way we do work and learning and growing together in that. So everybody have a good morning, evening, afternoon. We're from all over the world, so go do something fun and creative, since you're not actually an AI model and you can do that. All right, see you later, everyone. Bye.